Jain friends. In today's lecture, we will discuss first and follow and LL1 parser. Myself, Sachin Jain, Assistant Professor, Department of Computer Science and Engineering, Akgec Engineering College. So, these are the outlines of today's lecture. Then we will discuss the predictive parser, then first and follow, then parsing table, stack implementation, and its parse tree. Now, parsing. What is parsing? So, in the previous lecture, we have seen that the second phase of the compiler just generate the parse tree. So, parsing can be done in two manners. Either it can be bottom-up parsing or either it can be top-down parse. So, when the parser start constructing the parse tree from the starting symbol and then tries to transform the start symbol to the input, then it is called as a top-down parsing. And when we start from the input symbol and tries to construct the parse tree in such a manner that we reach to the start symbol, then this type of parsing is called as a bottom-up parsing. So, parsing can be two types, top-down and parsing. In top-down, we are just generating the parse tree from top to down, and we are generating parse tree from bottom to top. Here we are reaching the starting symbol, here we start from the starting symbol. So, the top-down parts, today we will discuss top-down parser. So, just combine that, I am just taking the top-down parser. So, top-down parser can be a recursive descent parser, and recursive descent parser further divided into two types of parser. Either it can be solved with backtracking approach or either it can be solved using the non-backtracking approach. Non-backtracking approach further generalized into the predictive parser, and predictive parser is a kind of LL1 parser. Here L is a left to right, here L is a leftmost. So, left to right, leftmost derivation is called as a LL parser, or it is a kind of predictive parser. So, predictive parser is a recursive descent parser which has the capability to predict which prediction rule is to be utilized or to replace the input string in advance. It doesn't suffer the backtracking problem. Basically, backtracking is a problem in top-down parser where we doesn't know which type of rule we have to apply to generate the parse tree. So, here confusion remains. Here there is no confusion. We know in advance which type of prediction rule we have to apply to generate the parse tree. So, in today's lecture, we only discuss the predictive parser. So, predictive parser uses the stack and the parsing table to parse the input and generate the parse tree. So, there are two important things. One is it uses the stack and it uses the parsing table. So, to generate the parse tree, we required stack and parsing table. So, both the stack and the input contains a AND symbol, that is dollar, that denotes that the AND of the stack, or you can say the stack is empty. The parser refers the parsing table to take the decision which actually which rules we have to actually apply. And here we can see that what we required three important things: input, string, second one is stack, third one is parsing table, and then this will generate the parse tree. So, parser required three important things. One is input string, second one is stack, third one is parsing table. And among three, two things are important. One is stack and second one is parsing table. So, in the various parsers, the only thing that differs is a parsing table. The construction of parsing table is important. That actually utilized to generate the parse tree. So, what is LL1 parser? LL parser is sometimes called as a LL key parser because it uses the key number of tokens to of look ahead when parsing the sentence. So what is K? K is the number of tokens. LL grammar, particularly LL1 grammar, the parser are easy to construct and many computer language are designed to be LL1 for this reason. So this is a simple kind of parser and many programming language works on the same parsing technique. Here one stands for, if we are writing one here, then one stands for using one input symbol for of look ahead for each step to make the parsing action. So here we are referring the one input symbol at a time. That's why we are writing one here. If we utilize two symbol at a time, then it can be LL2. But it generally we use one token at a time. So the name of full form of this one, as I told you, that it is left to right, leftmost derivation, and K is the look ahead symbol. So the primarily requirement of a LL1 parser is there should be no left refactoring and no left recursion present in the LL1 parser. Second important thing, we should know how to calculate first and follow of a given grammar. Then we will construct the parsing table, then we will do the stack implement, and then we will generate the parse tree. So these four thing actually we will process to solve the question of LL1 parser. So first step, as I told you, that is a calculate first and follow. For example, if we want to calculate calculate the first and follow of a given grammar, then there are certain rules that must be keep in mind when we are calculating the first and follow. So for example, rule number 1, for production rule x to epsilon, the first of this x will be this epsilon. So basically a terminal that actually in the right hand side of a production rule is called as a first of that starting letter. For example, if any terminal symbol is A, then first of this A will be A. For any prediction rule like this, in this example, we can see there is no terminal symbol in the right hand side of the prediction rule. Then we will just see that what actually the generating terminal using this first non-terminal symbol. So if there is a rule like x equals to y1, y2, y3, then we will see that what is the generating terminal of y1. If first of this y1 epsilon is not the first of this f1 y1, then the generating terminal of y1 will be called as a first of this x, right? If there may be possibility that y1 is generating epsilon, then we will look to the y2 and y3. Then again the same rule will be applied. We will see that what are the generating terminal of this y2, or if it is also producing epsilon, then we will see the generating terminal of this y3. And if there may be a case, then y3 is also generating the epsilon, then the first of this x will be epsilon. So in this way we will calculate the first of any rule or a non-terminal. Now there are certain rules to calculate the follow. The rule number one, if it is a starting symbol, then the follow of it will be dollar. Second rule is, if there is a rule like A to alpha beta, then follow of this B will be follow of this A. If nobody is following the letter that is at the end of the right hand side of a prediction rule, then the follow of it will be the letter through which it was generated. So if we want to calculate the follow of B from this rule, then the follow of B will be follow of A, because there is nothing that is following by B. Now, rule number 3 for any prediction rule A to alpha beta B beta, if you want to calculate the follow of uh, A, then follow of A sorry, if we want to calculate the follow of B, then follow of B is beta. Here we can see. But if this beta is a non-terminal, then we will check what actually the first of this beta. For example, there is a rule alpha B beta. If it is a terminal, then it's okay. Then the follow of B will be this beta. And if this is not a terminal, then we will check what is the first of this non-terminal. Then this first of this non-terminal will be the follow of this beta. And if this beta is producing epsilon, then the first follow of this B will be the follow of A, as per the rule of 2, right? So in this way we will calculate the first and follow. And for follow function non-terminal, by looking where it is present on the right hand side of the prediction rule, we have to note down that every time we will calculate the follow after seeing the right hand side of the prediction rule. Second note is, epsilon may appear in the first function, but epsilon will never appear in the follow of any, right? So in first there is no dollar, in follow there is a dollar, in first there is epsilon, but in follow there is no epsilon in the output of follow. Now, if we want to calculate the LL1 parser, then we need to calculate the second step, that is a parsing table. So how we will calculate the parsing table? Firstly, we will calculate the first and follow of a given grammar. So here we can see the first of this one is E. The first of E is T E dash. Here we can see that this T is not a terminal. Then what is the generating terminal with this T? Here we can see T generating F T dash. Here we can see again T F is not the terminal. Then what F is actually generating? F is generating E. So we can see the first of this one is open bracket. Again, F is also generating the ID. If we will replace this F to ID, then E is directly generating this ID. So in this manner, we calculate first of E, open bracket, and this ID. Now, similarly, E dash is generating first plus and epsilon. T is generating first terminal, that is a star, and ID. T is generating FT dash. T is generating FT dash. So F is generating again open bracket and ID. So open bracket and ID is the first of this one. T dash is generating star and epsilon. Here is star and epsilon. F is generating ID and open bracket. So ID and open bracket is the first of this. Now similarly follow, if E is the first letter, then the follow of this one will be the dollar. If we can see in the right hand side production here, E is following by the close bracket, then the close bracket is also the follow of this one. Now similarly, the E dash is at the right hand side, then all the rules that are generating, there is no follow of this one, all the follow of E will be the part of this E dash also. Now similarly, for T is present here, T is followed by capital E dash, and E dash is generating epsilon and epsilon. Then all the follow of E dash will be also the follow of this one. So in this way, we just calculate the first and follow of a given grammar as per the rules that we have studied here. Now, after calculating the first and follow, the second step is calculating the parsing table. So, how we will calculate the parsing table of a given grammar? So, first we will calculate the first and follow, then we will make the entries of this parsing table. So, in the left hand side, we will just write the non-terminal. In the upper side of the right hand side, we will write the all the terminals, that's called the input symbols. So there is a rule to fill the entry of this predictive table. First we will see the E to ID. So we will see the entry of first E to ID. This rule will be placed at the open bracket and ID. So we will see the first entry and we will put this rule in the particular cell of this table. Now, if there is no epsilon, then we doesn't need to see this follow entry. If there is a epsilon, then the rule corresponding to epsilon will be put as per the entry of the follow. So this is the important thing that we should know. If there is no epsilon in the first, then we doesn't need to see this follow. If there is an epsilon, then the rule corresponding to this epsilon will be put as per the entry of this follow in this table. So plus, the rule corresponding to plus will be put here, and if there is an epsilon, then the rule corresponding to epsilon will be put dollar and close bracket. So the dollar and close bracket contains this one. Now similarly, the rule corresponding, if there is no epsilon, then this rule will be put in two places, open bracket and ID, open bracket and ID. If then there is no epsilon, then we doesn't need to see this part. And in this, the rule corresponding to star will be put here in the star section, in the epsilon. Then the rule corresponding to the epsilon will be put at three places, plus, star, plus, dollar and close bracket. Now similarly, the rule corresponding to the ID will be put at place of ID, and the rule corresponding to open bracket will be put in open bracket. So in this way, we just generate the parsing table, or we can say it's called predictive table. Now this table will be referred for stack implementation or to generate the final parse tree. So let's see the next step. Now this parsing table will be used as a predictive table, and this parsing table will be used for stack implementation. So let's see the stack implementation directly. We will refer this table. So in the stack, we will put here the starting letter, and at the end there is a dollar. So input, for example, if we want to parse the string in id plus id into id. Now, how we will say it? E to id, E to id. So we will refer E to id here. Here the rule is E to TE dash, E to TE dash. So we will write in the opposite manner, TE dash. The rule is TE dash, but here we will write in reverse order. Now again we will see T to ID, T to ID, then there is a rule F2 T to FT dash. Then again we will refer this rule T to ID, T, this T, this ID, then we will refer this T and this ID, and the rule will be put here in the reverse order. Here we will write in the right order, here we will write the reverse order. Now F2 ID, this F2 ID, again we will refer this table F2 ID, there is a rule ID. So if ID and this ID get match, then we will pop out this one. Now remaining portion will be here. Now again we will write, here we can write match ID. Now T dash to E dash. Now T dash 2 plus. For T dash 2 plus we will refer T dash 2 plus, there is a epsilon. So this is vanish. Remaining part is E dash 2 plus, we will refer this one E dash 2 plus, E dash 2 plus this rule. So, but we will write in the reverse order, plus T E dash. Here plus and plus get match, then it both the things will be pop out. Then in the similar manner, T to ID, FT dash will apply. Here we will write in the reverse order. F, there is a rule F2 ID, then ID and ID get match, then this will pop out. Here T2 star, there is a rule FT dash, we will write in the reverse order, then star get match here. Then F2 ID, there is a rule F2 ID, then this ID and ID get match, then remaining part is T dash E dash. Then again T dash to F dollar, there is a rule that's called epsilon. E dash to dollar, there is a rule E dash to epsilon. So at the end we can see there is a epsilon dollar, there is a dollar. So we can see that all the letters we have processed, when there is a match, then the things will be pop out, means we have generated the tree. And if there is no match, then we will just replace the matching rule, and this matching rule can be found from referring the predictive table. Now we will expand our parse tree in the similar manner in which we just convert the rules, right? So when there is a match, 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 we just convert the rule. So in this way, this tree is generated. So first E is converted into T E dash, then T is converted into F, then this tree is converted into T dash. In this manner, we just generate the parse tree. So thanks all for today. Thank you.